Okay. Okay.
Sir, or else
Now
you
this
can
set
make.
will be
You
done.
told that you will make a YouTube video on the paper
I
discussion.
wanted to make, man. Yesterday day before yesterday I was having to arrange one marriage. I attend one marriage because of which I could not do. I am sharing the paper right now as you asked me. Just now I am sharing the paper and discuss. Don't worry. I kept the paper in in your group. Can you see? Hello? Can you see the question paper now?
Yes.
Yes, sir.
No, that I will be discussing. Don't worry. What is the IUPAC name of this compound, sir? It is not a big deal. It is 2-cyclopentyl. Yes, it is 3-cyclopentyl. Sorry, 3-cyclopentyl. 1, 2, 3, 4, 5, 6, 7, 8. Octane. What is the big deal in this? Hello. Everybody got 4 marks simply for nothing. 3-cyclopentyl octane, sir. Any difficulty is there? Hello. Hello.
No, sir.
No, sir, not difficulty.
What is the IUPAC name of this compound? Okay. So there is no functional group. If there is no functional group, okay, chloro I respect, because in alphabetical order C comes first. It is 2,4-dinitro, 1 chloro, 2,4-dinitro, benzene. What is the big deal in this? What is the difficulty in this? Hello, sir. What is the difficulty in this? You tell me.
Nothing.
This is benzene, right? There is no function group. Okay, I started with 1, 4, 1 chloro, 2,4-dinitro, benzene. I don't know what is it. There is no difficulty. You got 8 marks for nothing. Okay, again IUPAC name. CH2, CH, CH2, COOH. The 3 carbons have COOH groups, means all will get equal priority. So now IUPAC recommends to name like this. Propane 1, 2, 3 tricarboxylic acid.
Sir, why
Or
carboxylic? We can write trioic acid.
the recommendation to call it as tricarboxylic acid. IUPAC made a special recommendation for this type of compound. Okay. Next, 16. CH2OH. It is having 2 carbons, so eth. Between carbons, single bond N. Ethane 1,2-diol. Is there any big deal in this?
No, sir.
Hello. You have to keep last E. Ethane 1,2-diol. Next, IUPAC name of this compound. Always you should see to it that the double bonds get the highest priority. They should get the lowest number. So you will be counting like this. Okay, sir. Then what is the name of this? 6-chloro, cyclohex, 1,3-diene. Notice
Sir,
it
we
has
can
6
give 5
carbons.
chloro now, sir.
Sir, you are counting this 1, 2, 3, 4, 5, 6. Chloro is there on 6th carbon. Why should you say 5? That's the only way, because
Where you
you may
kept 2, we can count
no, you
1,
may
2,
think
3.
like this. Should I number like this? If
No,
you number
sir.
like this, double bonds are not getting lowest number. Double bonds should get lowest possible number. Here, double bond sum is 1 plus 3, 4. If you number in any other way, double bonds will get more number. This is the only way.
Sir, 6 chloro is not given in options. There is no
Mama?
Yes, sir. There is
Yes, sir?
it's not an option,
no
sir.
Sir?
option with 6.
No option with?
6 chloro.
What is second option? 5 chloro. Oh, they made a mistake. This is must be 6 chloro, right? The position of Cl was wrongly printed. Actually, it could be 6 chloro. There is no correct answer for this. I cannot help. This question is to be add mark. I did not see. Just now I am seeing. So, I am sorry for the mistake.
Every action
Okay.
are mistakes.
It is a printer's devil. What is the name of this compound, sir? What is the name of this compound? Can you think?
Vinyl.
2-cyclopentyl ethene.
So, this is a functional group ethene 2-cyclopentyl, or I would say 1-cyclopentyl. Always I can count like this, right? 1-cyclopentyl, or simply cyclopentyl. Cyclopentyl ethene. What is the IUPAC name of this compound?
Sir,
What could be the
in
IUPAC?
option they gave it as cyclopentyl ethylene.
Actually, that is a mistake. Cyclopentyl ethene is the name. Cyclopentyl ethene, not ethylene. Ethylene is common name, right? It's a printer's mistake again. Okay, I will be carefully examining now. Actually, I thought that there are no errors in this. Okay. Okay, sir. Let us look at this question. IUPAC name of this compound?
Sir, you left the 19th one, sir.
19th one.
कौन खेला
The structure of 3 bromo prop 1 in. Prop 1 in 3 bromo. Oh. See, no, it is C. This is the structure. That is the structure. Obviously, 3 bromo prop 1 in.
दादाजी आते ना नाना को आते ना वो बोलते कौन सा
Option 4 is right. Star. పిల్లలకి హాయ్ చెప్పా సారి హాయ్ అను పిల్లలకి అప్పుడే హాయ్ అనుకో ఆల్ ఆఫ్ యూ ఆన్సర్ టు దిస్ క్వశ్చన్ ఈస్ 4th option.
Right, first option also we can write, no, sir.
No,
Alphabetical order.
first option is wrong. First option is 2 bromo prop 1 in. They wanted you to write 3 bromo prop 1 in. 3 bromo prop 1 in means 4th option. Okay, all of you, are you there with me now?
Bromo means option 3, sir.
Yes, sir.
3 total. There are 3 carbons, sir. Nonsense. I'll see. There are 3 carbons, so prop. Okay, this is double bond 1 in, prop 1 in. 1, 2, 3. Third carbon has bromo. 3 bromo prop 1 in. Obviously, the fourth option. What is the doubt in that? Oh, yeah, fourth option. What is the key given? What is the key given, man? Hello?
Fourth one is
What is the key given? Fourth one only, no?
Fourth one only, sir.
Okay, sir. Okay, now the systematic name of this compound CH, CH3, CH3, COOH. Obviously, 1, 2, 3. It is prop on oic acid, propanoic acid. On the second carbon, there is a methyl, 2-methyl propanoic acid. Okay. Now, isomerism. The number of primary alcohol isomers for C4H10 100 times we have seen. It has total 4 alcohols like this: 1 butanol, 2 butanol, 2 methyl 1 propanol, 2 methyl 2 propanol. Out of this, primary alcohols are 2. 1 and 3 are primary alcohols. So total how many primary alcohols it has means 2. C4H10O has primary alcohols 2. All alcohols together is 4. Ethers are 3. Primary, secondary and tertiary amines are. Primary amine is this. I will take this. Yeah. For example, this is a primary amine. This is a secondary amine. This is the tertiary amine. IUPAC name of primary amine in this case is propanamine 1. It is IUPAC name of this compound is N-methyl ethanamine. IUPAC name of this compound is N-dimethyl methanamine. All these 3, 1, 2 and 3 are functional isomers. Primary, secondary, tertiary amines are functional isomers. Are we very clear, sir? Hello.
Yes, sir.
Primary
Yes.
amine has NH2 functional group,
Yes,
secondary
sir.
amine has NH, tertiary amine is N. Okay, next. Which of the following compound is isomeric with trimethylamine? Trimethylamine means this one. Trimethylamine. Trimethylamine. Trimethylamine is isomeric with propanamine. 2-propanamine. They have same formula. Both 1 and 2. So, trimethylamine is isomeric with primary amine, 1-propanamine, 2-propanamine, and both 1 and 2. It is not isomeric with 2-butanamine because 2-butanamine has 4 carbons. Isomers have same formula, same number of carbons. Last question. Which of the following classes of organic compounds show metamerism? Metamerism is seen in compounds which have bivalent functional group like ether, like secondary amine, like ketone, like ester. Yes or no? So answer is all the above. I don't know, this question paper can be completed in 5 minutes. Just 5 minutes. Okay. Now, today a lot of work is there. I want to talk. Did we talk about stereoisomerism, geometrical isomers, sir? Hello? Hello?
Yes, sir.
Yes, sir.
Did we talk about enantiomers?
No, sir.
Okay. Then we will be starting our talk on that. Today I will be sharing some 30 slides with you. I go fast. This book also, these slides also I am sharing. Small errors are there, you correct yourself. Did we, about 2 fellows have joined. When I am about to take the class, if somebody joined, that's a nuisance. Please don't, now I will not take anybody. Now I have to close admission, okay? Because going back means costing us time.
And the PDF of this
Now
note.
latecomers I don't take today. Okay? Sir, did we talk about conformers?
Yes, sir.
Hello? A form of stereoisomers in which the isomers can be interconverted exclusively by rotating C single bond C are called rotamers or conformers. This way of writing a rotamer or conformer is called Newman projection formula. In this, the center point in the red lines, the dot is first carbon, the second black circle is second carbon. We are here looking at butane. What is the molecule we are looking at? Butane. In butane, if the methyl group on second carbon, methyl group on third carbon are facing each other, covering each other, that is called eclipsed. If they are very far away as possible, then it is called staggered. The forms which are there in between are called skew forms. What they are called?
Q.
Skew forms. Always completely uh, staggered form is more stable, then partially staggered, then eclipse. For butane. Look here. These isomers are formed by rotation of CC sigma bond. Alkane can have infinite number of conformers. Rotation around C single bond C is not completely free, though somewhat slowly it moves. Okay. The repulsive interaction between the groups which are similar on both carbons is called a torsional state. Ethane molecule contains C single bond C. Therefore, it can show conformers. Methane cannot show conformers. Why? Why methane cannot show conformers, sir?
Because it has only
Hello?
one carbon atom.
Perfect. No CC bond. If you don't have family, you need not have to go for family planning operation. If there is no CC bond, there is no conformer. Keep one carbon atom stationary, rotate the other carbon atom. This rotation results in infinite number of conformers. There are two extreme cases. One such conformation in which hydrogen atoms are attached to two carbons are as close as possible. Eclipse. As far away as called stagger. They can be represented in Saar's form or Newman projection. Projection means drawing something 3D on 2D paper. In Newman projection, molecule is viewed at the CC bond head-on. Carbon
Sir,
atom near
today
the
you are
hydrogen.
sharing this slide, sir.
What did you say?
Today you are sharing this slide, sir, in WhatsApp.
I will share. Okay,
Okay,
don't worry.
sir.
The problem is it is not there in my mobile. It is there in my tab. Whatever is there in my mobile, I can share. In a tab, sharing is problematic. But I'll see. Okay, sir. Please read this. It's not there, man. Mobile is not there. Okay, try to share after some time. Now, next, we talked about Newman projection, right? This is the dot is near carbon, big circle is rear carbon. This is staggered form. This is eclipsed form. The forms in between are called skew forms. Always staggered conformation is more stable than skew. Skew is more stable than eclipse. Do we know that? Now, optical isomerism means what? A pair of isomers which have object and image relationship. that rotate plane polarized light in different directions are optical isomers. Optical isomers that are mirror, image and object form, which don't cover each other, are called enantiomers. For example, you try to cover your left hand with the right hand, keeping both head on. You should place both of them in the same direction. You can't close the left hand with the right hand. Molecular ion that exists as a pair of enantiomers, that is object and image forms, said to be optically active. They are said to be exhibiting optical isomerism. Look at your left hand and its mirror image. Your left hand mirror image is like your right hand. Can you see it? Yes or
Yes,
no?
sir.
Yes.
Yes, sir.
Now, if you vertically place up left hand over right hand, it cannot cover. The left hand thumb is going towards left. Right hand thumb is coming towards right. They can't cover. Notice both of them can differ also in one property. If one molecule which is looking like an object rotate plane polarized light in the clockwise direction, the other pair can rotate plane polarized light in anti-clockwise direction. What is plane polarized light? Ordinary light vibrates in infinite directions. If ordinary light is passed through a Nicol prism made with CaCO3, you get plane polarized light that vibrates in one direction only. The plane polarized light, one enantiomer rotates in clockwise direction. Its mirror image, another enantiomer, rotates in anti-clockwise. That which rotates clockwise is called dextro-rotatory. Sir, have you ever eaten dextrose sugar? Dextrose.
No, sir.
Hello? Have you ever eaten glucose D?
No, sir.
Glucose D, glucon D. Yes or no?
Yes,
The
sir.
glucon D means that is dextroisomer, that which rotate plane polarized light clockwise direction. If you eat glucon D, you get energy. If you eat glucon L, its mirror image, simply it will get out through urine. It means in a pair of enantiomers, in a pair of optical isomers, one may be a good medicine, the other one can be a great poison. So this phenomena where such compounds exist, object and image relation, they are stereoisomers. Look at the lactic acid. In milk there is a lactose sugar. A kind of bacteria, lactobacilli, convert lactose into lactic acid. If this is formed in milk, दूध फट जाएगा. Now I want to give you a task, sir. Look at the lactic acid, give its IUPAC name. Hello, look at the lactic acid, give the IUPAC name. Please. Here I want to say, sir, something looking like a solid wedge. Solid wedge is indicating group coming towards you. The OH is coming towards you. Something looking like a broken wedge. The hydrogen is going away from you. The COOH and CH3 are lying on the plane of paper. The H is going away from you. The OH is coming towards you. This is a way to represent three-dimensional molecule and a two-dimensional paper. It is called wedge dash representation. What is it called? Wedge
With your
dash.
dash.
Sir, do you know the angle between COOH and C and CH3 is? What is the angle between COOH, C and CH3?
109 degree.
Exactly 109 degrees, 28 minutes. Okay, sir. What is the IUPAC name of lactic acid? What is the IUPAC name of lactic acid?
Hydroxypropanoic acid.
Hydroxypropanoic acid.
2-hydroxypropanoic acid. Sir, it is called plus lactic acid because it rotates plane polarized light in the clockwise direction. Clockwise direction is sometimes called rectus. See its mirror image. The mirror image is also said to be S lactic acid. S means synictus. R means rectus. S means synictus. Rectus means right. Synictus means left. Notice R and S isomers have object and image relation. Yes, sir. What is the IUPAC name you said? 2-hydroxypropanoic acid. Look at this sugar called threose and another sugar called erythrose. Both threose and erythrose have same formula, but they are differing in the orientation of OH groups on second and third carbons. Can you see them? Hello?
Yes,
Yes,
These
sir.
sir.
isomers of sugars where all OH groups and all carbons are on the same side. Everything is there on the same side. Everything thrown in the same side is called erythrose. Everything is not thrown in the same side. The OH are on the opposite side is called threose. These are the sugars which contain 4 carbons. Yes, sir. This pair of compounds called threose and erythrose, they don't have object and image relationship. You can't convert one into the other. You have to remember what is erythrose. Erythrose is a sugar where every OH is on the same side. Threose where every OH on carbon is not on the same side. That pair of compounds which are not looking like object and image, but still they have same formula. They are non-superimposable. One cannot cover the other. They are called diastereomers. What they are called, sir?
Dash.
What is the difference between enantiomers and diastereomers? Enantiomers have object and image relationship, optical isomers. Diastereomers are not having object and image relationship and they are non-superimposable. Okay, very good. Now we are entering into a very important part. We have completed all the preliminaries. We are going to very important point called reaction mechanism. Your doubts, sir?
Sir, geometrical isomers.
Sir, we have prefinals.
Sir, geometrical isomers, sir.
Sir is busy.
Hello?
Yes, sir.
What happened? I think we got disconnected.
No sounds are coming.
How many minutes back it got disconnected?
3 minutes. 3
3
minutes.
3
My God, I was struggling. I was talking so many things and like a madman. What I was talking to you when you were hearing last?
You told called, do you have any doubt?
About what?
Isomer.
Sir, now
We
let
are
us talk
starting
about
a new
reaction
topic.
mechanism. Now we talk about reaction mechanism for a minute. Sir, what is the reaction?
You not did screen sharing, sir.
Don't worry about screen sharing. I am asking you what is the reaction? Hello, sir. What is the reaction, sir? Yeah, what is the reaction, sir? Can anybody tell me? Hello, sir. Hello. Can anybody tell me what do you mean by reaction? Are you hearing me?
Yes.
Sir,
A
what do you
chemical
mean by
Yes,
process
sir.
in which substance act mutually on each other.
a reaction is something where something changes into something different.
Products
You
change
go
to
as a
reactants.
happy man to home,
Reactants change.
your father, you go as a happy man to home, your father identifies you and scolds you, then you get out as an unhappy man crying. Now a reaction happened. The starting situation is different from the final situation. Yes or no?
Yes, yes.
Yes, sir.
It's a total
Notice any change or transformation is called reaction. Now, in chemistry, one material is converted into different material. The basic material which is changing is called substrate. What is it called?
Substrate.
Substrate.
When the substrate is added with a reagent, you have to add something. Then this will change into a unstable intermediate. That intermediate ultimately becomes one or more products. The main thing which you want is main product. All other things are called byproducts. So every reaction has a starting material, B, a reagent. When you add reagent to a starting material called substrate, you get a product. Sometimes you may get unstable intermediate which changes to product. You are very clear? Intermediate is a stage in between reactant and product that is very, very unstable. Now let us see what it is. During the course of a reaction, existing bonds will break, new bonds will form. Therefore, every bond, if there is a married couple A and B are wife and husband, can they marry again?
No.
No,
Now,
sir.
if they take divorce, there can be two marriages. Always one divorce is equal to two marriages. Why they want to take divorce? They think that they are not happy together. Now, why they want to go for new marriages? They think that new marriage will give more happiness. Okay. So, H2 plus Cl2 gives 2HCl. The bond between HH breaks. The bond between Cl breaks. Now, new bond forms between H and Cl. This entire process, bond breakage in H2, bond breakage in Cl2, formation of HCl, the study of entire process together is called reaction mechanism. And in the course of reaction mechanism study, we notice first there is a bond fission. First existing bonds are breaking. How do they break? How do they break, sir? इसमें दो तरीका हो सकता है. In first mode, are you there, sir? Hello?
Yes.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
First
Yes,
mode,
sir.
a bond
Yes,
breaks
sir.
such that both atoms get one electron each. That is called homolytic fission. The fellow who has one electron is called free radical. Free radicals are highly reactive. Always homolytic fission can happen in presence of UV light or high temperature or in presence of peroxide, hydrogen peroxide, benzoyl peroxide, some peroxide. Sir, can you look here? UV light can bring about symmetric breakage of layer bond. So A is getting one electron, A is getting one electron, fellow getting one electron is called free radical. E then is undergoing homolytic fission, you got two methyl free radicals. Always homolytic fission require less energy. It happens in presence of light or peroxide. Heterolytic fission is second category. Breaking of a covalent bond in such a way that one fellow gets both the electron, one fellow becomes the gas. My God, somebody is making noise. Now I am muting you all. Mute all. Very good. Now I will share this screen. Sir, homolytic fission, heterolytic fission are two variants, sir. Homolytic fission is simple, requires less energy, you get free radical. Heterolytic fission requires more energy, you are getting plus and minus ions. Sir, in a heterolytic fission, if you get C plus, CH3 plus, it is called carbocation. In a heterolytic fission, if you are getting C minus, it is called carbanion. So, in the course of bond rupture, there can be homolytic fission. You can't see the screen because it is getting fluctuated. Today, the noise is also getting distracted. I don't know. Okay, never mind. I used the whiteboard. I will use the board. Come on. I will be using board. Yeah. Ladies and gentlemen, no rejoining. No rejoining. Tomorrow we'll continue. Today the system is fluctuating. How many minutes are there? Hello?
Less than 1 minute.
Less than 1 minute, sir.
Then I'm closing the meeting. We'll be meeting tomorrow. Try to read the textbook. I try to share it.